Hello everyone, good morning, good evening or good afternoon, depending on where you are. My name is Jakub and I'm very happy to be able to speak for Warsaw Java user group, even though it's a remote meeting, but taking into account all of the situations that we have right now and the fact that we are all locked at homes, I'm happy to be here even remotely. And I'm going to talk about testing. Love, hate, love. What does it really mean? And why the subtitle is Love, Hate, Love? So I've been traveling around the world past years as software consultant, and I've noticed that we, and by we I mean the software development industry, have polarized emotions towards testing. So I have met teams, I have met people, I have met organizations who would say that every single line of code needs to be tested. Even though, sometimes it doesn't make sense, or just between us, in fairness, sometimes it doesn't pay off. So I call it a platonic love. On the other hand, there are people who would say, yeah, we've heard about testing, it sounds like a good idea, but not in our specific project, not in our specific context. In this context, testing doesn't work. And they feel betrayed by the idea of testing because in their context, it doesn't work. So there is hate towards testing. And I came to the conclusion that we need not polarized, but balanced, pragmatic way of choosing the right strategy of testing depending on the problem we face. This is why I do this presentation. This is why I came up with this idea, and I must share something before we start. I consider myself a lucky developer. Ever since I've joined the second team in my so-called programmer's career, I've been doing software unit testing, and I've been doing that pretty well. At least my teammates used to say that. But even though I've been taught how to do that from the very beginning, almost, I was doing that subconsciously. Like, it was in my blood, but I didn't know all of the guidelines, all of the principles that made me make some decisions. And it hit me 5 years ago. I was doing a presentation on refactoring. And when you talk about refactoring, you probably are going to write a lot of unit tests during live coding, right? So I did that. And after the presentation, one person came to me and he asked, what shall I do to make such beautiful tests as you? And I said, hey, you know what? It was just a presentation. Probably your project is longer than 45 minutes, or lasts longer than 45 minutes. Yeah, his next question was, what shall I do to teach my team to write tests which are useful? And it made me realize that before that, I had been testing from my subconsciousness, and I had to do the knowledge transfer from my subconsciousness to my consciousness. And this is where it all began. So we sat together with this person, let's call him Jack, because his name was Jack, and we took a look at his code, at the code base of his teammates and also Jack's code. And I cannot copy-paste all the things I've seen there, but I tried to mimic the design problems they were facing in a small code sample for the sake of this presentation. And here is that. That's a small class, or small is a subjective statement. It's a leave service. Leave service has one public method. It's called request paid days off. It takes two arguments, days and the employee ID. And it's invoked every now and then when an employee wants to go on vacation, right? So what it does some validation, loads some data from the database and maps it to an object, an array of objects. Why not? This is how some projects implement it. Then we get some specific data from this array. Then we start decision making. So in Poland there is a general rule. I'm simplifying that, but let's put it that way, that you can get up to 26 days per year of paid days off. But in our case, even if you have more and you are so-called top elite performer, a key player at your organization, you can get up to 45, but all of the requests from 26 to 45, they had to be processed manually by an escalation manager. That's why we notify the escalation manager. And I'm not making this up. I have recently met a person who works at an organization, and this organization, they really have escalation department and escalation manager. How cool is that? And I said, I have to use it in my presentation. So it is. Even if you are this top elite performer and you want more than 45, I'm sorry, but the request will be denied and you will get a nice email saying that maybe next time. If you want less than 26 and you are a slacker, meaning you play PlayStation all day long, we deny all of your requests with a nice email. Maybe next time. And then eventually, if you are a regular employee, you want less than 26 or equal or up to 26 days, then we approve your request. We send back to the database new data because we need to increment used days so far. And we also send an event to a message bus, of course, taking into account the transactional boundaries of database call and message bus call, saying that, hey, request was approved, maybe there is an HR service which is interested in that. So as simple as that. And what we did with Jack, we sat together and we tried to test this code. Almost copy-pasting the strategy of testing that we were choosing for the sake of other classes. So we came up with this design. I'm not saying that's the best design for the class, I'm just trying to mimic the problems they were facing, okay? So we have one class, leave service, and the leave service has some collaborators, right? So we inject them. Those will be stubs or mocks. And for Jack, it was pretty easy to write down all of the use cases or test cases because he knew that system pretty well. We didn't have 5, of course, we had close to 50, and we started implementation one by one. So let's do it that way right now. The first test case says, hey, requests of performers will be manually processed after 26th day. So given a person in a database who is a performer and has an ID equals to 1, then please, dear database, return this array of objects. Performer with already used days equals to 10. When we want more, so we contact the leave service. Let's say we want 30 more, which in total is 40, right? That should be manually processed, right? So I'm expecting that the result is what? Is manual. I'm also expecting that verification escalation manager will be contacted, right? That's a crucial thing. Verify escalation manager called one time with a proper employee ID equals to 1. Also, we would like to check that things that we don't expect to happen will not actually happen. So I'm checking that no email will be sent, so no interactions with email sender. Same when it comes to message bus. What else? I'm expecting no more interactions with database, right? Because we are not sending back anything. So let's see if that works. Cool. Let's copy paste and try to implement the second test, which is for performers trying to get more than 45 days. So in this case, what? I have 10, but I want 40 more. Overall, I want 50 per year, which, I'm sorry, cannot be allowed, even if you are a top elite performer at the organization. So the request will be denied. I'm not expecting escalation manager to be called, but I'm expecting the email sender to be called with a specific method parameter. And the content of the email is that. Next time, right? As far as I remember. Verify no interactions with escalation manager, verify no interactions with message bus and with database. Let's see if that works. Cool. It's green, meaning we can go and implement the third one. Let's copy paste this one. And that one says what? Slackers, they don't get any leave. Fair enough. If you are a slacker, so let's change the status. You just want 1 day. Maybe it's there is an online contest, PlayStation-like things. I don't know. You want to go there, but the request will be denied. Let's see if that works. Cool. Let's copy paste that one and check the regular employee. So regular employee just wants more than 26 days, which means the request will be denied, right? Regular, what else? 10 plus 20 means 30, which cannot be accepted, right? That should be green. Cool. And the last one. The last one is eventually the happy path. So I'm a regular employee, right? Oops. I'm a regular employee. And what else? I just want, let's say, 2 days more. Request should be approved, right? Email shouldn't be sent. So I'm expecting no interactions with escalation manager. I'm expecting no interactions with email sender, but I'm expecting an interaction with message bus, send event, request approved. Cool. We should get rid of that. And I'm finally expecting some interactions with the database. To be more precise, I need to verify if database was called, save method was called with a proper argument. In this case, it's going to be an array of objects because that's our API. The status hasn't changed, but we changed the number of days. 10 plus 2 equals 12. Let's see if that one works. Cool. Great. So we did that. And Jack said that, you know what? Every now and then, there is a change in business requirements. Like imagine, but business people sometimes they change their minds, and it happened in their project too. Like for instance, we changed the content of the email, and if we run the test right now, of course they will fail. Some of them will fail, even though the logic behind, hey, shall I get some days off or not, didn't change, right? So we know why it happens. Of course, it happens because our they test too many things at once. So how to correct that? Probably we are all aware that the first test should be checking just the decision. So I'm going to copy paste that. I'm interested in the decision, and the second test should be checking, for instance, the email content if we are interested in that. It doesn't care about the decision, and let's rename it to Slackers get a nice email. Of course, probably we should have more of those. Each observable behavior that we check interactions with should be in a separate test case. Probably we should be doing that with all of the tests we have written so far, but for the sake of the presentation, let's just correct the slacker and just like split the test into two. And now let's see if that works. So now we are expecting only one test to be not green, and that's correct because here we had this. So let's return to the previous solution, and now let's run the test one more time and see what happens. They are all green. So now the tests are depending on less things, right? So they have less reasons to fail, which is good. And Jack said that also every now and then, since this class quickly became a so-called God class, they keep adding dependencies to it. Like I'm adding configuration, for instance. Why? You might want to ask. Because, for instance, we don't want this magic number of 26. We want it from the configuration. A very simple change, right? Max days, and the same with 45. Configurations get max days for performers. Of course, if we run the test right now, all of them will fail with null pointer exception. We all know why it happened, because we didn't inject the configuration into our test case, right? So let's do so. And imagine now we have 50 cases. So we have to go to the 50 cases and teach something when it comes to what should configuration return when we call getMaxDays or getMaxDays for performers. So we should create stubbings for each case, and we have 50 cases or 100. So I'm not going to be that stupid, and I'm going to do it before each, right? Of course, that's not a good solution, because now our tests, they become less maintainable. I have to jump back and forth from the test and to the setup phase to see what actually is going on. But this is what they've been doing, so I'm going to do so. Mockito, when configuration getMaxDays for performers, getMaxDays, return 26, and the second case is as follows, and getMaxDays for performers, 45. Let's rerun the test right now, and some of them will still be failing. As you can see, in fact, only the tests related to performers are green. Why? Because only those two tests, they care about all the stubbings we have created. So both those things. Mockito is a very smart tool, and it says that, you know what? In all of those test cases, you are stubbing too many things. Probably you have no idea what you are doing. You are stubbing just random things, which creates tests which are not clean and maintainable. As you can see, it complains about this stubbing. So one way to fix that, that's a bad way of fixing that, but people do that. It's just disabling this warning or settings. But yeah, as we said, it's not a recommended way of fixing that. We should actually do our job and use these stubbings where it's needed. And it's needed in here. It's needed in here too, right? And now if we run the test, they should be green without cheating. All right. The third and the last thing that Jack mentioned is that, you know, every now and then we change something in the database, like we add columns, we remove those. The ORM tool, if we have one of these, changes something, and it all results in some data being at a different index, like 5, for instance. Of course, all of the tests will be red right now, even though the logic didn't change, right? Even the email content hasn't changed throughout this change. So if you are under pressure and you have to deploy that hotfix very quickly, because there is a manager behind your desk and behind your chair, some people started doing things like this, so ignoring tests, or running build without running the test phase. Both of them are, I would say, not a good way of developing software. So we need something different. We need to think about, because that's what happened to, we need to think about our design, because that's what happened to Jack's team. They developed a strong hate towards testing. And why is it so? Is that the problem with testing? They should be blamed? Or maybe that's the problem with the design, and the emotion of frustration should be directed at the design, not at the test or testing tools. So let's ask a simple question. What does the leave service do? And that's a very stupid question you might want to answer, because yeah, it decides, right, whether you go on vacation or not. That's its responsibility. All right, is that its only responsibility? In my humble opinion, it also validates input data, right? It also loads some data that's needed for the decision to make. It also finally reacts to that decision. So maybe it escalates, maybe it sends an email, maybe it contacts the database, or maybe it sends an event, and so on and so forth. So it does many things at once, and it would have been easier if those steps were sequential. But what we do is this. We have some validation, then some decision, then some loading, then we load some more, then we stop and we do a decision. When it's manual, we react. If not, maybe we decide whether it's approval. If not, or it is approval, then we react, and so on and so forth. So even though we can write tests which check only decisions, like we have done with Slackers, and separate them from tests which check reactions, and we have done that too. It doesn't prevent anyone from jumping in here, dropping a bomb like with this index from our array, which means all of the tests in here will be read, or if the bomb is dropped in here, all the tests will be read in here, right? So that's problematic. And why is it problematic? So we as industry, we talk a lot about something which is called single responsibility principle. So the module, the class, the microservice should do one thing and do it properly. But no one knows actually what that means. I'm not going to pretend that I know, but everyone says that. So at least I know what SRP is not. That's not SRP. Too many things in one class. I know systems where, for instance, the reaction to the decision is postponed in weeks, like business systems. And inside of those business systems, we have small parts which are actually software systems that serves as a part of the business system. Like in Poland, when you get a ticket for overspeeding, you can actually get, there's a limit of tickets you can get before you need to return your driving license and pass the exam one more time. And when the policeman hands you the last ticket, when the decision is made, so you have to return the driving license, actually the post may with an explanation and with information that you should give away, you should give back the driving license, you should return that. It's postponed in 3 weeks. Don't ask me how I know it. My friend told me that it works that way, and I believe him or her. Anyways, we do too many things in one place. So let's try to fix that. Let's try to divide responsibilities into separate classes, or at least separate private methods, and see what happens, okay? Let's jump in here and see how it goes. Oops, not in here, but in here. All right. Here is validation, right? The first 3 lines. I guess you can imagine how we extract this to a separate class. I'm going to leave that for the sake of this presentation, but because that's a very simple exercise, right? Here we do some decision making. I'm going to move it to here because here we have decisions mixed with reactions, right? Like email sending, escalation manager that we contact, etc., etc. Here we have loading. Let's leave it for a while and let's focus on this, decisions and reactions. You know what? I would like the reactions to stay here and the decision-making process to be extracted to a separate class. So let's try to do that. I'm going to create a separate class. It's going to be called something. I have no idea how to call it yet, okay? What we don't need probably the days, we don't need the RF objects because we want to get rid of that API. Days so far and status, that's something useful. Okay, let's create that. What else? Let's create a variable like this. Okay. And that's probably part of loading the state, right? We should load something and then thanks to something we can make a decision, right? We can fix that way, I guess. Oops. Cool. So let's also rename this method. I don't like invoke. Let's call it request paid days off. That's better, right? And let's pass days in here that we want to use, which means we have to add parameter. All right, result. And then let's start writing reactions. So if the result was manual, we are going to do something. This something means we need to contact the escalation manager, right? If, not one, but employee ID, if the decision was denial, then we do something different. By something different, I mean we need to send an email. Email next time, right? And last but not least, if the result is approval, then we do what? Message bus, please, I want to send an event to you, which is called request approved. What else? We need to contact the database too. And I would like to save back something, which means we need to change the API somehow, right? The mapping should be responsibility of the database or something which is between our class and the database class. So let's delegate it to database for a while. So probably we don't need this. I want something to be directly returned from here, like this. Which means that's just a step for the sake of the presentation. Probably here we have SQL statements or ORM mappings, something like that. Return null, and let's pretend that we are returning something. Okay. Something is private class of live service, which is a mistake. I want it to be separate class. Maybe package private, that's better. All right. Which means we can get rid of this. And when we save, we don't save the object, the array of objects, we save something, right? Cool. So now, so far so good when it comes to reactions. So here we have decisions, and here we have reactions. Cool. So let's fix this. We probably don't need this line, neither this line. Reaction, 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 database, reaction, message bus, reaction. This is decision, right? Results. So we keep the results and only results in here. This is the state change, which is crucial. And here what? Let's get rid of that variable. I guess we don't need that. And just return result, which means we don't need this. Oops. Which means we don't need this, right? And now what we have to do, that's the last step, is think about configuration. That's the part when we get to ask ourselves a question, which wouldn't have been asked, or it would have been harder to ask this question with the previous design. Are those two numbers specific to something class, or maybe something instance, or let's call it an employee maybe, or are those numbers global for the whole application, meaning each instance of something gets the same number? That's we have to ask it right now because it doesn't compile, right? So if that's per instance of something, that means we can easily create very elastic and configurable design. But you know what? For the time being, let's put it that way, like it was. Going to be easier, but at least we get to ask and answer this question, right? All right, we haven't been taking a look at the tests. We should be doing that, so let's fix this mistake. They are not compiling. So first of all, let's delete the configuration here and here. And what else? We need to fix something in here because our database is not returning array of object right now, array of objects, but we need to return the something class, right? Let's do it. Let's do it that way. 2, 3, 4. That's the last one, I guess. New something, and we get 1. And this is something we need to get rid of, and this as well. What else? And this. I hope it compiles. It compiles almost always, except for this last test, which makes sense because first we load something, regular employee, and then we expect that's going to be saved to the database because we changed the state in that case, right? So it should be here, what? Regular. And now if we run the test, we can see if we did some mistake, but seems like we are good to go. So it was a very simple change, right? We moved some logic to here. We changed some logic behind the loading from the database and saving back to the database. So what is the conclusion from here? Previously we had a class, that's the X. It had very huge complexity. Complexity meaning huge amount of if statements, which at the end of the day somewhere change the state of our application, right? Days so far equals days so far plus days. So a lot of if statements like this. Also, we had a huge number of shared dependencies. A shared dependency is a class that's not only for our benefit, but also escalation manager and email sender, message bus will be used by different components of our system, right? So we have both huge complexity and a huge number of shared dependencies. And when you want to test that, it's not going to be easy. It's not going to be pretty. The tests are going to be fragile, and we will have a lot of use cases to test. We'll have so-called multiplication of test cases, explosion of those test cases. So if you have this class, which is both complex and has huge number of shared dependencies, probably we need to split that into two classes. And this is what we have done. That's our new live service, and that's our new class, which is called something. Live service still has huge number of shared dependencies, but it doesn't have complexity related to business problem. Something, on the other hand, doesn't have huge number of shared dependencies, but it has this complexity, right? Probably in some places we would have DTOs, so classes without complexity, without huge number of shared dependencies. Those things probably won't be tested because I don't need to test getters and setters. So we can find a sane conclusion. Like that's not we don't have to blame tests or the tools. We have to take a look at our design and maybe redirect this emotion of frustration towards our design, not towards testing itself. So there can be love. But if we take a look at our tests, and I've seen that many times, there are some tests, like that one, for instance, with slackers, the one that we split it into two. This one, in fact, doesn't talk about any mock or stop. You know what? This is useless, right, in here, because we can write this test in a different manner. We can have this, like this. We can remove this. We can replace slacker in here, remove one, and that should be green too. So we don't need stubs and mocks to test that, right? That's the business logic. But here we have just stubs and mocks. So we have some convention in here, other convention in there, and according to my experiences, there will be wars. There will be two gangs at an organization. One of the gangs would say, hey, we need to do with mocking. We need to test with mocking and stubbing and so on and so forth. The other gang would say, hey, no mocks, no stubs allowed, because everything in our code base needs to be the same. If it's not under one convention, that's useless, and we should get rid of that. And there is hate because there is no convention when it comes to testing. That's what they say. And if we think about that, for instance, you can read great blog posts by Martin Fowler about testing pyramid, right? In a firmly complex and nicely written business application, you have this shape of testing pyramid. But when you don't have that much business logic, or you have more presentation logic, or you are dealing with legacy, which is not that testable, but you still want to test that, probably the pyramid looks like this. It's reversed. It's upside down. If you have a system which supports only create, read, update, delete functions, probably your testing pyramid it's a rectangle, right? So we have different strategy depending on the problem, and the same happens when it comes to testing and choosing mocks over not choosing mocks. So it's described in this book. It's a great book, quite a new one, Unit Testing Principles, Practices and Patterns. And we have two different schools of testing. They come from the test-driven development movement. If we think about dependencies that our class can have, they can be divided into shared ones, meaning others will be touching those dependencies too, and private ones. And then, in turn, private ones will be mutable and immutable, like value objects, for instance. And there are two schools of doing testing. Classical school, aka Detroit style or Chicago style, would say you should only be mocking shared dependency. That's it. Everything else have to be created from scratch if you want to test a class which has like private dependencies. There is also other school called Mocky style or London school, which says you should be mocking more. Also, private mutable dependencies should be mocked because it doesn't make sense to mock value objects, integers or wrappers for integer strings, and so on and so forth, right? So I'd like to take a look at this diagram from a different point of view. What we mock in a classical school, shared dependencies, and what we don't mock in London school, the value objects, right? So let's have an example. Let's say we want to refactor our class something. Let's say that this logic in this branch is complex. I want to delegate it to a new method, a new object. Let's call it too many days resolver. And imagine it's injected via constructor, okay? I'm not going to do that for the sake of simplifying the presentation. And same here, regular days solver. I have two classes because my class or my method is too big. I don't want it to be not readable, so I'm just using private objects, right? Like this. The test should be still green, by the way. Let's check it. Great. And now, if we go according to classical school, when we test something, we shouldn't be mocking too many days resolver or regular request resolver. Why? Because these are private mutable dependencies, right? And there is an objection to that way of testing. The objection is as follows. When your class something has huge number of public behaviors, and those public behaviors always rely on something from the lower level, like let's say too many days request solver. And if that fails, that class fails because you've introduced a bug, all of those tests will be read. So you'll have huge amount of tests being read, even though you have changed like one line of code. And the answer from people who are representatives of this school is as follows. You know what? I want to see that. I want to see how many crucial business functions depend on this small class. I want to see that. That's desirable. Other objection that it's sometimes being said towards this style of testing is, hey, if your something has 10 dependencies, private ones, and each of those 10 dependencies has 4 dependencies, meaning you have 40 dependencies to create when you want to create a simple test for a class called something. And again, the answer is very reasonable, I would say. Yes, I want to feel that pain. I want to feel that pain. Don't take it away from me, because maybe if I write that down, I see that something is wrong with my design. Probably I have too many dependencies, right? So this is how they say about the objections. But let's talk about London School. London School would test it that way. Something with 2 mocked or stubbed dependencies. Too many days request solver and regular request solver, right? And there is also an objection to that way of testing, and it is as follows. You can over-specify your algorithm. You can couple your test to the implementation details. If you change the way you handle this logic behind something, request days paid off, and you introduce a third class, or you change the name, or you change something in the parameters, the test will fail, even though the behavior hasn't changed, right? So you do small refactoring and the tests are failing, even though you didn't change anything when it comes to business logic. So you can over-specify the algorithm. Yeah, I'm a representative of classical school, so I agree with that. Let's take a look from the higher level at those two schools. If you want to test a leave service with the classical school, that means I need to mock escalation manager, email sender, message bus. These are shared dependencies, but there is also a private mutable dependency, which I'm not going to mock, right? It's called something. But if we choose the London style, then probably something as a private mutable dependency should be mocked too. So we have different schools depending on different problems. But what is the rule of thumb? So I have my own rule of thumb. It looks like this. The class which has a huge number of collaborators and number of shared dependencies is going to be tested with mocks if I want to test it at the unit level. And the class which has huge amount of complexity, but it shouldn't have huge number of shared dependencies, I don't want mocks or stubs there. I want to test all of the things as the entire unit, right? Other rule of thumb I have is this. In my head, when I see the dependency, I try to inline this dependency to the original class, to something like this. I'm going to do the drag and drop, right? And I take a look, what happens in my head. I'm just introducing a new variable if I do that, right? Days. Is my something right now less cohesive or not? Do I introduce like fields which are not related to something? If not, that means that those classes are only introduced for the sake of readability, but the cohesion is still the same. These are private dependencies. I'm not going to mock or stop that. But if I introduce fields like, hey, gateway URL, gateway credentials, things like that, probably I have been testing too many things, and probably I'm talking about shared dependency like payment gateway. So in this case, I'm going to stub it or mock it. So there can be love. We can choose a proper tool depending on the problem we face. Another thing that I've heard many times, and I used to say that out loud all the time, TDD leads to a great design. I'm super sure you've heard that too. And let's do a small experiment. Like, let's do TDD almost by the book, okay? Almost. I'm not going to do the proper cycle, but it's going to be more or less TDD. That should be source, main, Java, test here, yeah. And the TDD, product test. So let's take a look. We have this. We have some tests to be implemented. Let's say we are implementing a product catalog, something like that. So every product has a serial number, as simple as that. So I'm going to create a new product. 1, 2, 3, the serial number, not in this package, but in this. Create class, great. Serial number. All right, create field, good. That should be final because every product should have serial number. We have only one default constructor. We're good to go, I guess. We can delete that test. It led to a certain design, but now it's useless. We can be deleting test cases if they are useless. So the second test says as follows: bot product is not available. So we start with the assert. So what's the assert part? I want to make sure that product P is not available, right? If I buy it. So let's import assert false. And that one, good. When someone is trying to buy this product. Which product? Given product P, new product 1, 2, 3, right? Let's introduce those two behaviors. And the last one. Of course, the test will be green right now just by accident. Let's just implement that. It looks like a, I don't know, enumeration or Boolean. I'm going to do the first option, enum status available bot, which means we need a field for starters, private, final, not final, status, it's available at the very beginning, right? What else? When we buy, we want to change the status to bot, and when we check if that's available, we just compare. Okay, looks like we are good to go. Let's run this test. It's green, great. Another test which says, hey, I cannot change the price of a bought product. So I have a product, someone buys that product, and someone else tries to change the price, which doesn't make sense because it's already bought, right? I cannot cheat that way because maybe someone wants to reissue the invoice and they will get different price, which is against the law, by the way. You can go to jail for that in Poland. Okay, change price, which means we need to have a price in here. This price equals price, int price. I know it shouldn't be int, probably something like a value object, but you know, just a presentation. If status equals bot, then what? Throw new legal state exception, for instance. Create this field. Good. Oops. Let's move this in here. Change price to 10. Then we are expecting that exception is thrown. Illegal state exception. When? When someone wants to change the price to 10. Oops, like this, I guess. Which means we don't need that and this. Expect. Let's try it. It's green, great. Can change price of an available product. That one is easy, means I have a product, no one bought it yet. I want to change price, so when P change price to 10, then what? Assert equals expected 10, P get price. Right? Create method get price, return price. Then let's run it. That should be green. Good. We have certain design, right? We cannot deny that. And you know what? After 2 weeks, business person comes to us and says, hey, you know what? Give me a new feature. I want products which are visible in the product catalog, but they're not available. So you can just have them in the database. They are visible, but you cannot buy them. Why? Because if someone actually wants to buy them, they will call and then we'll agree on a certain price. We actually don't have it yet in our warehouse. We'll just buy them if someone's interested. That's an experiment. Okay. So given a product, I guess, but those products, they don't exist. So shall I pass a serial number? They don't have serial numbers. We learn from business experts, for instance, but we already have unique constraint on database, not null constraint. We have final fields. So I'm going to create a special field, a special serial number. It's called catalog, but I'm not stupid. They will come with more products like this. So I'll have _13. That's my design. And that should what? I'm expecting this product to be not available. Let's run it. Doesn't work. I have to change something in here probably. If that's a special product for catalog, price, not price, but serial number contains catalog word, keyword, then this shouldn't be allowed. I mean, it's not available, right? I know I'm exaggerating with this design, but I'm just trying to follow blindly just the steps of TDD, which is a great tool. But let's see how it goes. And you know what? Those things which are products without serial numbers, they don't have price, right? Which makes sense because they don't exist. So we agree on a specific contract with our front-end team that when someone asks for the price, if the product is this special product which we just make visible for the sake of an experiment, so catalog, serial number contains catalog, then we return -1, which means they have to display a small thing which looks like a telephone because the client is supposed to call us, right? And we can go and on and on and on with that. Probably we don't like it already, right? There are some decisions which are not great when it comes to how we understand a clean software. But we've been following TDD from the very beginning, right? What I'm getting to is that some people would say that TDD rocks, some people would say that, hey, it's useless, and there is big hate. So I would like to actually create a balanced opinion on that, or just think about balanced opinion on that. This sentence, TDD leads to a great design. Let's take a look at each word from this sentence. TDD, that's super obvious, leads, obvious, to a obvious, great design. What does it really mean? design. What is design? Do you mean encapsulation and friendly API? Then yes. Thanks to TDD, we are there. We are also experiencing testability. Why? Because we've been following TDD. Yes, TDD led to testability and good naming, because the naming, it comes from the test scenarios, right? It's easy to refactor. The tests are not coupled to the implementation details, and so on and so forth. So when we think about design in that way, TDD leads to a great design, but it's polished from the outside, but it's not going to prevent us from building something which is completely not mirroring the reality of business needs, right? So it can be pretty and shiny, but in fact, inside, when it comes to business, they mean something different, right? So what is design? If we think about this thing, like we have product description with just an abstract thing, like a description of a book, and then we have products which are identical, like identical physical copies of the book, and then maybe some unique handwritten book, which is still the same description. By the way, that's called a product archetype, business archetype, which was created many years ago, and it's just generic problem which seems to be present in many different domains, but under different names. Like in here we have product, but it can be book, it can be an agreement, things like that. So we didn't finish with that thanks to TDD, right? So the conclusion would be what? TDD does not lead to a great design? Bad news, right? Good news is that TDD does not lead to a bad design either. So what's the real news? We, as programmers, as architects, we lead to a bad/great design. We are the responsible people who actually make the decisions, so we shouldn't be blaming our tool for our decisions. That's a tool. By the way, it's called test-driven development, not test-driven design. It's development. It's a technique for analytics. It can help you with specifying what's your target by the sake of writing down test scenarios, and then step by step in a safe manner seeing how they become green. If the business people change their mind, so we move the target somewhere else, we have different set of scenarios, and then step by step in a safe manner we can be sure that we are going towards the target. That's why we use TDD. We can create bad code thanks to TDD. We can create bad code without TDD. I can create great code without using TDD. I can create very bad code after doing TDD. I've done plenty of those. So the thing is that it might be that you feel in your domain that your way of doing TDD sucks and the whole tool sucks. It doesn't. Just if that happens, probably we should be learning more about the domain, about the problem we are trying to solve. Probably we should be learning more things about archetypes like product and accounting, manufacturing, etc., etc. Because TDD plus domain knowledge, it leads to a great design, right? And there can be love, there can be specific way of doing, of using a tool without creating a useless emotion which is called hate. All right. Next thing I have noticed many times is this. It happened to me last time after a big conference in Texas. One person came to me and said, you know what? How can I convince my people, and this person was in charge of a huge software development department, like hundreds of people. How can I force them, he said, how can I force them to do unit testing? And I asked him, hey, but what have you done so far? And he asked, hey, I told them to test, because if they do that, if they force themselves to test, their bodies, their organism will get used to that. That's what he said, really. I'm not making this up. And their reaction should have been that, hey, if we are going to punch you in the face each day, your organism will get used to that. But okay, they couldn't say that out loud. I couldn't say that out loud either, because that would have been my last business trip probably. But anyways, they didn't want to do that. He wants to do that. There is a big hate between them. So how to solve that? And he was attacking this problem from a wrong direction, from a wrong angle. And it was already proved in late 80s by three gentlemen called Pollack, Cook, and Sullivan. And they were doing an experiment on saving energy. So they said that within 2 months, during 2 months, they will be checking how much energy a certain household is using. And people who are going to save the most of energy within 2 months are going to be recognized in a local newspaper. So they tried to build this belief that, hey, saving energy is important thanks to this pillar of fame, of audience, of I'm going to be recognized. But they were smart gentlemen. They knew that during those 2 months, people would build more important pillars like self-esteem, which is better, more money, right? And what happens after 6 weeks? They actually saw that the energy metric is lower than it used to be. But they announced one thing. They said, you know what? We are not going to publish anything in the newspaper. So our local logical reasoning would say that the energy usage should go back to the initial state, right? But what happened is actually people were saving even more. Why? Because the only pillar who would make them believe that they were doing that for the sake of being recognized and not for themselves was gone. So that was an experiment which worked out. And the person responsible for this huge business and development department, he was trying to build this belief of writing tests, again, on the same pillar of audience. He was talking about code coverage. He was trying to give away some prizes for people who are creating huge code coverage, etc., etc. But when people came back to him saying, hey, if we want more tests, we need to do some refactoring, he didn't allow that. He didn't allow refactoring. He just cared about code coverage. Thanks to that, people couldn't build those more important pillars like less bugs, more fun, better code, better self-esteem. The only pillar was this. It was quickly gone and no one was writing tests because he was talking about code coverage. Let's talk about code coverage. I have a small sample in here. It looks like follows. Code coverage is a metric which says how many lines of code a certain test invoked, right? So that's a very simple test. New product which is available, let's test if it's available. Let's run it with coverage and see what happens. As you can see, 88% of code coverage is accomplished thanks to this test. 8 lines out of 9. Let's see which line is not invoked. As you can see, only that one is red. This. Right? But if we think about business cases, even though we have coverage equals to 88, the business coverage of different business use cases, branches, it's 50, right? Because we only test this. And you know what? I had a really bad day trying to code this logic, and my IDE says that, hey, you can simplify that. And let's rerun now the same test with coverage. And as you can, I guess you know that this test is now going to say that we have 100 code coverage, 100%. But still we have 50% of business cases, right? So this is what I think about code coverage. It's a nice metric, but just the beginning of conversation. It's not a goal. Because it can lie to you, right? We should be talking about branch coverage. So how many use cases are we actually covering? Like in both those two examples, we covered 50%, or delta coverage, which is a nice metric, but it's hard to measure. But we can think about delta coverage. What's delta coverage? Delta coverage is a unique value which is brought with a single test. And it should be unique. If it's not unique, that means that other test gives me the same value, which means one of those tests is useless. So the value would be like this. Is it green if it's supposed to be green? Is it red when it's supposed to be red? Right? And what does it give it to me when it's red when it's supposed to be red, and if it's green when it's supposed to be green? What's the value? And is it unique? Right? So if we talk in those terms, probably there can be more love between people who would like to test and people who would like to just write production code. But I guess you've experienced a different situation where developers, they wanted to test, and the managers said that, you know what, we are not paying you for writing tests. We pay you for writing production code. It's going to take 2 times more time, right? So we as developers, we tend to say, but we need to be, you know, craftsmen, and we need to follow this idea of software craftsmanship. But is that really a nice explanation for business people? Like, maybe there is something different. Because otherwise we have hate. We want to test, they don't want us to test things. Because there is a naive perspective sometimes which is present when it comes to business people. They think that time of development is equals to time of coding. Time of coding is equals coding production plus coding test, right? And thanks to the law of transitiveness, we can deduct that time of development is equals to coding production plus coding test, which we know is not true, right? Because if that would be true, that probably means that some of the business people who say, hey, we don't need testing, they would be right, because there is a second factor which makes the time of development longer. But time of development equals production code, test code, plus integration to the current features, plus bug fixing, right? And guess what? Those factors, they are correlated, they are not independent. Meaning that if we put more energy into the second factor, like testing, then probably we are going to spend more time on integration and bug fixing. So there is correlation, right? And the correlation means that there is a certain point where testing pays off. Because if our system has a very short life cycle, like we have to deploy our software in 2 weeks, and it's going to last for 2 days because we have to handle some Black Friday thing or something like that, and then we are going to trash the system, hey, probably manual testing is good enough. It's going to be quicker. But if we need to make progress later on, then the investment for testing is going to pay off. There is a certain point. So there is a situation where testing, automated testing, is useless. We can do manual testing because we are going to trash the system anyways. It's not going to be maintained. I sometimes try to draw this picture from a little bit different perspective, like this. You know what happens when the curve flattens? You probably are aware or met a person who is beloved by the business people and hated by a development team. It's a person who would solve their problems but trashing the whole design. Like, the system is useless after this. That's why the curve goes to the left. I call it Sebastian's point. Why? Because I've met Sebastian who once did that, and it wasn't his fault. I'm just making fun. Hi, Sebastian, by the way, if you're watching this. Anyways, with Sebastian or without Sebastian, there is a point where it makes sense. So there can be love if we talk it through that way. Last thing I would like to talk about is testing legacy system. Like, let's imagine you have this leaf service, something, too many days, request solver, regular request solver, etc., etc. And then, at some point, you have to test, you have to replace this design because it's useless. It has to be trashed. You have to do refactoring, but you have to change the structure almost in every place. So you won't have something, you won't have too many days request solver, regular request solver, etc., etc. So the only sane way of doing that is to take a look at the behavior that leaf controller invokes when it comes to leaf service, and then just test this boundary with all of the optional behaviors, and then replace the whole thing which is inside of this boundary. But that means integration testing, and then there will be some person who would say integration testing is slow. And thanks to you, Jakub, Now our build time increased from 40 minutes to 40 minutes and 45 seconds, which is not acceptable. I'm not going to merge this PR. There's hate because we cannot do integration testing. But if we talk it through in a different manner, like if we try to write down what are the principles of good tests, like can I still refactor code? That's a good test if I can refactor code, right? Does it protect me? Is it fast? So we have 3 pillars of a good test. And then, in my opinion, you cannot get 3 at the same time. And some people, I have no idea where I've seen that, but I've seen this represented almost as cap theorem. So you always get to choose 2, and you can always be on the side of this triangle. In my opinion, you can optimize, you can be inside. Like here, there is integration testing. You can refactor because they are coupled only to the behavior from the outside, and then the huge part inside can be changed, so you can refactor. It protects you. Why? Because it checks huge amount of observable behaviors, so it gives you huge protection. More protection than unit testing, which is in here. Why? Because unit just by definition test 1 unit. You cannot check whether 3 units cooperate correctly with each other, but you can still refactor the unit. I have no idea what's here. Like that's something which should be fast and something which should give you protection. So I think about this as if you have a use case which goes from HTTP controller to database and you mock every single line of code or stub it and check that every single mock was invoked in the test, which means you cannot just change a single line of code because the test will be broken, then that should be something which is marked by this question mark. But that's useless, right? If you want to have this feature, that's there is probably a better way of solving this. We can just forbid people from pushing to master, right? So different testing strategy like unit testing, integration testing, depending on the context we have, like is it a legacy system or not, that's still solvable when we discuss that. There can be love. That's all I had for today. Thank you all for watching. That was testing love, hate, love. And I wish you a great day. If you have any questions, I'm happy to answer them via Twitter. It's @Jakub Pilimon. Bye-bye.